Hey everybody, welcome to Eureka Math / Engage New York Math, Module 6, Lesson 4, Creating a Histogram. Now a histogram is really similar to a bar graph that's kind of turned on its side. The difference is that the horizontal axis, so you have a graph that looks like this, the numbers here look like a number line and they have equal intervals. So it might be, might be 1 to 2, 3 to 4, 5 to 6, right? It's not like 1, 3, 7, it's intervals, so basically it goes in between sets of numbers, and it's how often something appears. And again, unlike a bar graph, they all touch each other. So as you do your bars, this would be the frequency of how often something appears, which you'll see in just a moment. Make sure that the bars in the histogram touch each other. Okay, let's go through an example. This is a little bit hard to read, so I'm going to read it for you really quickly. The boys and girls basketball team at Roosevelt Middle School wanted to raise money to help buy new uniforms. They decided to sell baseball caps with the school logo on the front to family members and other interested fans. To obtain the correct cap size, students had to measure the head circumference, which is the distance around their head, of the adults who wanted to order the cap. The following data set, which is the data set is all the numbers, all the information in the set, represents the head circumferences in millimeters of the adults. So for example, we have 513 millimeters, 525 millimeters, so on and so forth. The caps come in 6 sizes: extra small, small, medium, large, extra large, and extra, extra large. Each cap size covers an interval of head circumferences. The cap manufacturer gave students the table that shows the interval of head circumferences for each cap size. The interval 510 to less than 530 represents head circumferences from 510 millimeters to 530 millimeters, not including 530. So basically, if your head circumference is 510 millimeters up through 529.99 millimeters, you would go in this category. And so they measure all these heads, they have all this data, so we're going to go through real quick and we're going to first tally. Now this is a frequency table, meaning we're going to find out how frequent these numbers appear. But this is not a histogram. We'll create one of those based on this data. So I'm just going to start reading and crossing off. We have 513, I would go here. 525 would go here. 531 would go here. 533 would go here. 535, 535. Let's do that would go here. 542 would also go here, so that's 5. 543, okay. 546. 549. 551 goes in the next column down. 552, 552, 553, 554, and 555. So that is 1, 2, 3, 4, 5, 6. I'm sorry, 5. I already did 1. 1, 2, 3, 4, 5. 560. 561. 563. 563. 563, 565, 565, this one's appearing quite a bit, 568, 568, gives us 15 there, 571, 571, 574, 1, 2, 3, 577, 580, 583, 1, 2, 3, 583, 584, 585, 1, 2, 3, 591, so jump down here. 595 will be here. 598 will be here. 603 will be here. 612 is going to be in this bottom one, and 618 will be in the bottom one. So now we're going to count the frequency that these appear. So from 510 to 530 millimeters, or less than 530, we have 2. From 530 to 550, we have 8. We have 15 in this next one, then we have 9, then we have 4, and then we have 2. So we're going to use this information here to then create our histogram. Now they've already started this for us, so we're going to just finish it and answer a couple of questions about it. So I want to just point out, they have a title here. You always have to have a title. They tell us the frequency. So on this side, that's how many times each of those numbers appear. Down here, it tells you what you're measuring. So it's head circumference in millimeters. And then you see 510 to 530, 530 to 550, 550 to 570, 570 to 590, 590 to 610, and 610 to 630. Those are all 20 apart, so they have the same intervals. And the bars that we use are touching. So they've already done the first two for us. So they've done this and this. So you can see they had 2 and 8, which is exactly what we counted. Our next one is going to be 15. So this section here is going to go up to 15. So I'm going to go up and actually mark 15 first. So I see that this is 16 and that's 14. So it's going to be right in the middle. That's going to cover this whole column. It's not the best because it's hard to draw on this, but you kind of get the idea. So from 550 to 570, that's this column here. I'll color it in the best I can, right? So we can see that from 550 to 570 millimeters, there's 15 people. So we're going to get that size hat. Going back, our next one is going to be 9. So there's 10, there's 8. We're going to go right in between the two. And we're going right up against this other bar. Okay. Then we end up with 4 and 2. 4, you see, is over here, so that line does match up. There's 4, and then here's 2. All right, so this is our histogram. So we can look at this and we can tell a lot of information. Okay, for one, based on this histogram, what would be the center of the head circumferences? What would be right in the middle? Well, right in the middle is going to be that 550 to 570. So we would say probably around 560, right? It's kind of right in the middle there between 550 and 560. How would the histogram change if you added head circumferences of 551 and 569 to the data set? Well, the 550 to 570 would add 2 more, right? So right now it's at 15, so we would have to put it up at 17. So if you add more numbers, you have to increase the size of your histogram, okay? Now, one of the things that's different about this from, say, a dot plot is that here we just see a range. We know that there are 15 people who are in this middle range here, 550 to 570. So we know how many caps to order that would be. 550 to 570 would be medium, right? So we'd have to order 15 medium caps. If you use a dot plot, you would see the individual sizes. Here we don't know what all the sizes are. We just know there's 15 who are in that range, because that's all we need to know. Now, if each hat could be like literally fitted to the millimeter, then yeah, maybe we would want to know the individual sizes. But for this kind of information, we don't really need that. Now, so why would we use a histogram instead of a dot plot? Well, when you look at this, this is a range. And so let's say there were 300 pieces of data. Like we had a pretty good chunk here, right? There were a lot of numbers, but we didn't have, 100 or 200. So by doing a histogram, you can have a range of data. By doing a dot plot, you'd have to be putting those dots above each number, and you'd have to be, doing 200 different dots if you had 200 different pieces of data. So when you have a lot of data, that's when using a histogram like this really makes sense, because you don't have to draw as much. You don't have to spend time making sure that you get everything right. You have to, you have to get it right, but you want to make sure that you don't, accidentally put an extra dot or whatever. Here you just count them up, you do your range, you're good to go. All right, that's all the time we have here. We're going to talk more about this in class, and thank you for watching. We'll see you soon.